So first we do have a definition in here. We're going to be talking about bearing in this. So the bearing is an acute angle. What does acute mean? Less than 90 degrees, formed by the north-south line and line L. Okay, so if I have bearing, we are thinking, think about a compass. Think about your directions. Okay, your bearing is, this is my starting point. If I have an angle here, the bearing is this angle between the north-south line and that line. When we see bearing, there's two different notations. One of them uses N or S. What do you think those stand for? And E or W. And it's all in reference to the starting point. So if I said, this was 45 degrees, from my starting point to my ending point, do I go north or south? North. Then you put your angle, which is 45 degrees. And then we do our east or west? West. Never eat shredded wheat or soggy waffles or whatever your saying was. So to get from here to there, you go north 45 degrees to the west. Or you might see a single degree measure that's measured clockwise from due north. So if I were just giving that one, it's from due north, how many degrees clockwise would we have to spin to get here? So we know all the way around is 360, so it would be 315 degrees. Those would be the two notations for that bearing. Bearing comes up a lot in navigation. Military uses bearing for a lot of different things, even if surveyors, people that go out and measure properties and give legal descriptions of land. If you ever buy land, you will see a legal description and it has bearing references in it. So it is something that is actually used. Here, let's just practice giving the bearing from point B from point A. Okay, so if I start at A, what would I do to get to point B? Yes. You travel north, then you turn 40 degrees to the east. What if I did the other notation? The second notation is from due north, how many degrees clockwise? Isn't that just 40 degrees? If I start right here, just to that point. All right, this one, from point A, how do I get to B? 65 degrees to the west. Or, second notation, from due north, how far do you have to spin to get there? All right, third one, from A to B, how far do we go? So we travel south 70 degrees to the east, or from due north, how many degrees would this be? Lots of different numbers being thrown out. Yeah, we know all the way down would be 180, right? So if you back up 70, 180 minus 70 is 110. D, sorry. So from A to B, how would we travel? South, 20 degrees to the west. Or from due north, how far is it? 200 degrees. And I apologize, I decided to put one more on here that I didn't put on your handout. I forgot to update my handout. This one, if I'm going to B, we go north 0 degrees. Am I traveling east or west? Neither one. So in that situation, you can say east, or you could say west, either one would count. Degrees from due north, what would I say? 0 degrees. So if it lies on an axis, you still need the 2 directions, but you just pick one. It doesn't matter which. All right. The key to this bearing is if you have a bearing, it is measured from a north-south line. So we are going to practice reading questions and drawing pictures to go with them. Just like before, when we did angles of elevation and depression, we always had to draw in a horizontal line. If I'm doing bearing, I'm going to have to draw in a north-south line. Your pictures are your friend here. Don't try to draw this itty-bitty picture that you can't write any information in. Okay, make sure it's big enough that you can label the stuff that you have. So let's look at this problem. Radar stations A and B are on an east-west line 8.6 kilometers apart. What does that mean if they're an east-west line? Horizontal. Okay, so all I know, I have station A, horizontal line, station B. I haven't given any bearings yet, so we're just drawing this. We know the length here is 8.6. Station A detects a plane at point C on a bearing of 53 degrees. If I'm going to measure bearing from point A, what do I need to draw at point A? Yeah, we need the north-south line. So I'm just going to lightly draw in this north-south line. Okay, if I just give you a single degree measurement, that means from due north, I traveled 53 degrees. Okay, so it's saying this line from due north, that is 53 degrees. Okay, and that's giving me point C out here. Station B simultaneously detects the same plane on a bearing of 323 degrees. So now I'm doing the bearing from point B. So what do I need at point B? We need that vertical north-south line. Okay, my bearing, again, I only gave you a single degree. So that's saying from due north to get here. So that's saying from due north all the way around. This is 323 degrees. Find the distance from B to C. So I am looking for this side. Trig-wise, it's not that hard to find a single side in a triangle. But for our trig functions to work, what kind of triangle do we have to have? A right triangle. Did I tell you that it was a right triangle? No. So we can't assume, we have to check. Can we find some of our angles? If I know this is a north-south line and an east-west line, what kind of angle do a north-south and an east-west make when they meet? 90 degrees. So if you do 90 minus 53, you get 37. So I know this angle is 37 degrees. Okay, over here. I know from due north to right here would be how many degrees? All the way around is 360.
90.
This last piece is 90. So from here to here is 270. So do 323 minus 270.
52.
What's 53 plus 37? 90. So that means this is a right triangle. All right, I am now in good shape. I know I have a right triangle. So pick an angle. Can't be the right angle, but you can pick either of your others. I'm just going to say from this 37. If I'm going to set up a trig function from there, x would be my opposite. 8.6, that's across from C, so that's the hypotenuse. What trig function involves opposite and hypotenuse? So the sine of 37 degrees equals x over 8.6. So we multiply over the 8.6. Let's go ahead and do significant digits just to practice that. How many did we have in the problem? Yeah. 323 is 3, but 53 is 2. 8.6 is 2, so let's do 2 significant digits. So if I type in 8.6 sine of 37 degrees, we get 5.1756, which rounds to 5.2, and we were in kilometers. So 5.2 kilometers apart. All right, so the hard part on these problems, it's not the trig, because we set up a single trig function and multiplied over. We've done plenty of those. It's labeling everything in the picture to make sure we have a right triangle to do the trig. All right, let's try another one. The bearing from A to C. So I'm starting at point A. To get to point C, I'm giving a bearing. So if I'm going to measure bearing, we need a north-south line. So we are traveling north 64 degrees west. This angle right here, 64 degrees. I may have made this too close to my edge. Okay. The bearing from A, so now I'm back at point A, to B is south 82 degrees west. So I'm giving you another point from A. To get to that point, you have to go southwest. Okay, and that's 82 degrees. All right. Have I lost anybody? So now it says the bearing from B. If I'm measuring bearing from B, what do I need? So I'm at B now, so I draw in my north-south line. Okay, to get to C is north 26 degrees east. Now, it's just kind of coincidence that my picture was drawn like this. You very well may have yours drawn where like point C is all the way out here. Is that a big deal? No, we just fix it by shortening our line. We know that C has to be to the east of B. So just adjust the length of that line if it's not to the east. Okay, it was just kind of luck that mine turned out to be. If yours isn't, just shorten your line. So this angle is 26 degrees. All right. This is probably the most complicated bearings problem I might give you right now. Have I lost anybody on all of these angles? Okay. Do I know that I have a right triangle? No, nothing in my picture is drawn to scale. I can't even say, oh, looks like this should be a right angle. We have to make sure. How could I find angle A?
Take 180.
Yes, these three have to add up to 180, so add those together, subtract from 180. And we get 34 degrees. Okay. May not be perfectly obvious how to get the other one. But do you remember at the beginning when we talked about angle relationships? North-south lines are parallel. I have two parallel lines and an angle and a line going through them. So that tells us that this angle has to be the same as this one by alternate interior angles. Does everyone see that? So to get this one, what would we do? So So 82 minus 26 gives us what? And good news for us, 56 plus 34 is 90, so C is a right angle. All right, so I know I have a right triangle now. I know I can use my trig functions. Come back to the problem. A plane flying 350 miles per hour takes 1.8 hours to go from A to B. I'm giving you the information to find your distance. We have a rate and we have a time. How do we get our distance?
Rate multiplied by time.
So your speed is 350. You do that for 1.8 hours. And we get 6:30. Okay. We want to find the distance from B to C. So I'm looking for this one. All right, pick an angle to view from. It doesn't matter. If I did the 56, 630 is my hypotenuse because it's across from the right angle. If I'm using the 56, what is x? Adjacent, because it's touching it. What trig function involves adjacent and hypotenuse? Cosine of 56 degrees equals x over 630. So we get 352.29. How many significant digits did we have in the problem? These were 2. Since there's no decimal, 350 is also just 2. So this would be 350 miles if we round to significant digits. All right. How are we doing? Okay. I am going to jump around a little bit. Let's go to problem number 6. Or no, sorry, I'm looking at the high. Let's go to, let's do the second to last example. Okay. I want you to take a second and see if you can draw the picture for this. You don't have to try to solve it yet, just draw the picture for me. Boat, and it's going north 52 degrees 40 minutes east. So it's starting here. If I'm going to measure bearing, you have to have a north-south line, which looks like you guys were remembering that, so good job. And then we have to go northeast. And this angle that was formed is 52 degrees 40 minutes. And we're traveling that for a distance of 238 miles. How many miles east has the boat traveled? Do I have a triangle here? Could we make one? Yeah. We could really do 2 different ones. We could draw this triangle down here, but I think it's probably even easier to do this one because we already have the angle in that. Right? So if we just draw that horizontal line over, a north-south and an east-west would make a right angle. I want to know how many miles east, so I'm looking for this side. Okay, so from here, this is my right angle. Across from that we know is the hypotenuse. The side not touching it is my opposite. So what trig function involves opposite and hypotenuse?
Sine.
So I could say the sine 52 degrees 40 minutes equals x over 238. 52 degrees, 40 minutes, that's 3 significant digits. 238 is 3, so if I round this to 3, we get 189 miles. It's a more straightforward example, I think. Is that one okay? I want you guys to try the example right below it. See if you can get to the final answer on this one. So we have a starting point. If I'm measuring bearing, you need a north-south line there. And we're going northwest. For 79.5 miles. How many miles north and how many miles west has the boat traveled? So to finish your triangle, you have two options. You could draw the triangle like this, or just over like that. Which one's probably easier? Just going straight over because you already have both of those angles. Does that mean, or you already have an angle in your triangle? Doesn't mean you're wrong if you do the other, you just have to subtract from 90 to get your angle. So no big deal. But now we have a right triangle. We want how many miles north, so that would be this side, I'll just call it in. And how many miles west, so I want both of those sides. So from my angle, I'm going to move this. All right, if I'm using this angle, I know the hypotenuse is across from the right angle. Opposite is directly across, adjacent is touching it. So if I want to find north, that's adjacent and hypotenuse, what trig function? So the cosine of 37 degrees, 10 minutes. Equals n over 79.5. How many significant digits do we have in the problem? 3. So if I round this to 3 significant digits, we get 63.35, so 63. 63.4 miles. All right, if I want to find my west from this angle that's opposite hypotenuse, what trig function is that? So the sine, 37 degrees, 10 minutes equals W over 79.5. Multiply that over. And we get 48.029. So 3 significant digits be 48.0 miles. All right, how are we doing? I'm going to stop here for today. We are obviously not done with the section. I'm going to give you a handout, and it is due on Tuesday. So on Monday, we will work some more problems. We may or may not do all the problems on this notes handout. I tried to put plenty of examples if we needed them. We'll do what we need to, and then we'll finish up this handout. So it's 9 questions. You could do all of them. I'm not teaching anything new Monday. We're just practicing more. So take this time, start a few questions. The front side